I know that. Okay. Got it. All right. Welcome, everybody. Gary Embley, the current president of ISM New Jersey. Today, we just want to let you know of a few upcoming events we got going on. On April 14th, we're going to have the one-day conference at Supply Chain Innovation Day about the future of supply chain, and that'll be at Rutgers Business School over on Rockefeller Center. It's from 9 to 4. Speakers will include Jason Bergman, Melissa Drew, and Mark Raffin, and will feature a panel discussion on the people of supply chain, the talent. Next week, we'll be host of 2 webinars on February 8th, The Growth Mindset, a Game Changer in Performance and Well-Being on February 9th. Our ERP program will be Paul Farrell, Product Marketing VP of Oracle NetSuite. The information and registration can be found on our website, which is newjersey.ismworld.org. So now I'm pleased to let me introduce Tom Ramadi, the Executive VP of the Central Jersey Forum. Floor is yours, Tom.
Okay. Good evening. How you doing?
Great. Yourself?
Good. I just want to go over a couple upcoming events. We're always held, our meetings are the first Wednesday of every month. Other than December and this year in April, we have special events at Maggiano's restaurant. All the other months are Zoom meetings. So we look forward to anyone who would like to join us and join our mailing list. We'll be glad to send you out all our announcements. Our next actually in-person PDM will be April 5th at Maggiano's restaurant in Bridgewater Mall. We have L'Oreal's VP of Diversity and Inclusion speaking on that topic. It's going to be a special spring event at the restaurant. We have a great dinner with lots of gifts and prizes, and it should be a nice evening with our L'Oreal VP on site. May 3rd, we have a Zoom PDM with Peter Sherman, who's presenting on making process improvements stick. Peter has spoke with our chapter a couple times in the last couple years. Excellent speaker. We love having him back. He's based in California. June 7th is our a Zoom PDM TBD. I'm working with a couple speakers, but nothing lined up just yet. We have a couple of our board members online here that joined us tonight. Robert Russo is our treasurer, and Luis Gill is our VP and VP of a newsletter. So thank those guys for joining us, and turn it back over to you, Gary.
All right. So for our program tonight, we will be, the topics will be on smart contracts and blockchain. Please be sure to ask your questions using the chat to make this an interactive section. Our speakers tonight are Stephen Nichols, the founder of Banyan Business Outcomes, LLC, and Michael Spahn of Solutions Sales Director of Atmosera. I hope I said that right. I'm going to go turn this over now to Steve and Michael, where they'll tell you about their backgrounds. So welcome, Steve and Michael.
Yeah, appreciate it. Thanks, Gary. I'm Stephen Nichols. I'm the founder of Banyan Business Outcomes, and I've spoken a few times for the ISM New Jersey and Rochester and Dallas and a few different chapters around the country. So hopefully some of you guys have seen my face before, and maybe you're back for a second helping. And I'm joined today here by Michael Spahn. I'm going to share my screen. Maybe Kathy, let me know if this has any trouble sharing. 1 second.
You're good.
Yep, we see it.
Great. There we go. I asked Michael Spahn to join me. Michael Spahn's a good friend of mine and very knowledgeable about blockchain. Michael, do you want to do a quick introduction for you too?
Yeah, thanks, Stephen. Michael Spahn. I'm a solutions director for Atmosera. Very close. Thank you, though. You got my last name right, which is more important. So thank you. We are a fully end-to-end cloud consulting firm focusing on Microsoft's Azure cloud platform. We do cloud cost optimization and modernization of infrastructure, data, and application environments. I'm here in Denver, Colorado with Stephen, and I'm excited to be talking to anyone who's willing to listen about blockchain. So thank you all.
Yeah, I appreciate it, Michael. Thank you. I worked with Michael, of course, at a previous company, and left that organization to form Banyan Business Outcomes. So my company, just briefly, is an organization focused on helping businesses get better value from their spend, specifically with technology vendors. So I do work with sourcing technology vendors, contracting with them, and then managing to get the best value out of the relationship. And of course, reach out if you need more information about that too. So today we're going to talk about smart contracts, which is kind of an interesting topic, actually, based on blockchain technology. We'll provide a little context by going through some of the problems that we see with regular old contracts that have been around for 1,000 years or more. We'll talk about what a smart contract is and what blockchain is. So I have code as law listed there. That's really the nature of it. We'll talk through some applications of it, and that's really going to be where the balance of the presentation is focused. It's how are smart contracts impacting actual business people and actual industries. And a great example of that is how smallholding farmers get better access to insurance. We'll talk through carbon credits with healthcare, and then of course supply chain, which is probably going to be top of mind for many of the people in the audience today, I would guess. So yeah, as Gary mentioned, please do make this an interactive session. If you have questions, please drop them in the chat. I'll try and keep an eye out for those, or just feel free to unmute and ask the question too. That's always a little more engaging than me rattling on, but yeah, hopefully it's a great session, and let me know what questions you have. So we'll start with some context. Contracts have been around forever. This is an example of a cuneiform contract from 4,500 years ago. It was a marriage contract exchanging sheep for someone's daughter, which I think is kind of funny that you would need to write it down. Like, you think you'd be able to remember how many sheep were exchanged for a daughter. And then below that is a whaling contract. A contract is in written form, it's just a documentation of an agreement between two parties. And then there are verbal contracts that happen all the time. And that's just part of walking around in the world today is virtually signing these verbal agreements or contracts. A good example of that that illustrates some of the benefits of smart contracts is a situation that happened to me many years ago, more than I want to admit, when I was in a pub in North England. I walked up to the bartender and I put down a 20-pound note, and he gave me a beer and something like a 5-pound note back. And I said, well, that's an awfully expensive beer, isn't it? And he said, no, you gave me a 10-pound note. And I said, I think I gave you a 20. And he said, nope, it was a 10. And he just turned and walked away from me. And it's hard to say, at this point, that was if he was being untrustworthy, if he was trying to have one over on the American, or if it was a human error kind of thing. Maybe I thought it was a 10 or that kind of thing. I'm not really sure what exactly happened there, but I think the end result of it is I paid a whole lot of money for a beer in North England, and I got a story out of it, I guess. So that's an example of a contract, or an example of an exchange between two parties that didn't go well because of a miscommunication between the two parties, or perhaps something untrustworthy going on. Another example of that is relevant to smart contracts is when there's multiple parties. Another pub story is one day you're at a table, you order a pitcher of beer, everyone pitches in for that pitcher of beer, and then wouldn't you know it, you're short, and it come to find out somebody ended up not putting any money into it. So sometimes with multiple parties, with contracts that go through multiple parties, things can get confused, and you can end up with a bad situation, at least around beer, or perhaps something a little more meaningful than that. A second group of problems around contracts are third parties. Anyone who's ever bought or sold a house knows that the brokerage fees, the real estate agent fees can be quite high, quite expensive. It's also a long process with title companies and other organizations that have to approve the transfer of the sale. Other transactions require banks to be involved in escrow accounts. And then if things go south, you might go through a court, and the court may or may not actually understand the contract that's that's been laid out. So smart contracts are an opportunity for bypassing a lot of these issues with traditional or older style contracts because they have several characteristics that are rather important. They're deterministic, which means that everyone knows exactly what they're going to get out of it. They're immutable, which means that once a smart contract is substantiated, it can't be changed. It's distributed, which means that no one party really owns that smart contract. It's kept somewhere else on the blockchain. And it's transparent. Everyone understands what the code is like underneath the smart contract, so you're able to audit the way that that smart contract is going to work. And in fact, you can audit it to a greater degree than what you can do with a lot of terms and conditions in a regular contract, because the interpretation is deterministic, because you know exactly how the smart contract is going to work out. So a great example of that is what a vending machine looks like. Michael, you want to talk through that?
Yes. So why are smart contracts deterministic, transparent, and immutable, and trustworthy? Like Stephen said, a really common analogy here is a metaphor. It would be a vending machine, and to spice it up, why not make it a beer vending machine? Which everyone on the East Coast, you should be at least 2 deep by now. It's like, what, 7 o'clock out there? So the process would go as follows. This is the experience. You walk to the beer vending machine. It says $5 for a pint of beer, 16 ounces. You walk up to the machine, insert your $5. This initiates the code, aka the smart contract, that starts the transaction. I push the button for the beer that I want, and the beer is dispensed. The beer is only dispensed because of 2 conditions. The vendor has added beer to the machine's balance, and B, there is money in the account ready to be picked up by the vendor once the beer is dispensed. So if you've ever seen someone do the trick on the normal vending machine using the old dollar on a string method, you'd understand as to why a vendor might want to ensure that beer is not dispensed without the account or the transaction being funded. On the flip side, as a consumer, as the buyer party, a pint of beer is 16 ounces. For my $5, I want to be certain that I'm getting all 16 ounces. So an example of why this is an advantage over a traditional vending machine would be if the machine only has 14 ounces left, then the charge would only be $4.50 or whatever that works out to. It'd be hard to accomplish this with traditional methods. I've seen it done. Next slide.
Yep.
Thank you. So the 3 phases of a smart contract in this example would be first to fund the account. Now this account doesn't have to be associated with you, as it's simply a transaction block located on the blockchain, something I'll get much deeper into later on in the presentation. But the money is sitting in limbo. It's sitting in the middle of this transaction inside of the smart contract, because all of the conditions of the transaction have to be met before that money goes either back to the buyer or goes to the vendor once the transaction is either completed or not completed. So you'd select the beer, the middle part. The beer is then dispensed, at which the money is then sent to the vendor's account. So that's what a smart contract is. It's a simple set of instructions where all conditions of that contract must be met in order to complete the transaction. Next slide, please. So the reason I described it in such a logical manner is because anyone who's familiar with computer programming would understand that code is simply a set of logical arguments and variables that make up an application. So the real value here is that these transactions, every time I go to the vending machine and get a pint, and equally every time that machine is replenished by the vendor, that transaction is publicly or privately. In this case, it most likely be privately, and I'll go deeper into what the difference between public and private blockchains are later. But it's an area that neither I nor the vendor can modify once it's been set in motion. So not in the sense that, oh, hey, user ID 234512 is drinking 3 pints a day before noon, but in the sense that I, as the user, completely trust the vendor, and the vendor completely trusts me in that transaction. Next slide, Stephen.
Great, and we'll see a lot of examples of how smart contracts and blockchain can create trust where there hasn't been trust in the past. Through this presentation, we're going to be diving into examples and then back out to the technology several times. So we'll have maybe a dozen or so companies that we'll be talking about. There's a really interesting use case for smart contracts with crop insurance for small holding farmers in Africa. When we think of farms in the United States, we think of giant farms with giant tractors that are processing thousands and thousands of acres or hundreds of acres at least. And that's just not the way that it's done in Africa. In Africa, a small farmer may be managing just a couple of acres, and it's a family that's working on that property themselves. So it's a very different environment than what we have in the US. Those farmers probably don't have access to the same kind of technology that we have, and they may not have the same experience working with insurance companies and the same ability to trust those insurance companies to fulfill the obligations that they have. Now, this is important because farming is kind of a risky business. I'm actually somewhat involved in the agriculture industry, and the joke is that your business partner is Mother Nature, and Mother Nature is not a great business partner when you're a farmer. If you have really bad weather come through, it can wipe out the crop. And if there isn't any insurance in place, then the family is just going to be hungry until the next crop comes up, in a year. And that can obviously be quite a problem and create a great deal of food insecurity and income insecurity for the people in Africa. So the issue is they would buy crop insurance, but crop insurance policies would be extremely small because it's just a small number of acres. It's so small that it probably wouldn't justify the administrative overhead to process the policy. And they would also buy it, but they really don't trust the insurance companies or the government to come through if they need to see a payment. So if we talk through some of the benefits of smart contracts, and you see how this transparency, this immutability, and this vending machine-like experience allows these farmers to get access to the crop insurance that they need at a much lower administrative cost without the third parties or the middlemen in the way that slow things down and create additional cost. So the way these systems work really are 4 different steps. Just like with the beer vending machine example, you have to first of all put product into the vending machine. In this case, it's going to be a group of investors who put in some funds. They're putting something at stake, the $100,000 policy that will pay out in the event that the farmer has some kind of bad weather event that ruins their crop. So once that $100,000 or whatever the number is put into the vending machine or the smart contract, that instantiates the contract and allows the contract to become live so people can take advantage of it. Then the farmer is going to put in a sum of money, and they're going to create an account by doing so. And that is equivalent to putting money into the vending machine. So the smart contract then uses kind of what's called an oracle. In this case, it's chain linked is a version of that, to monitor the weather in the environment, or monitor the weather like literally where the farmer is located. And it can look for various conditions, but let's say it's 5 days consecutively of 95+ degree weather. We can all agree that probably a crop is going to be ruined after 5 days of 95 degrees. And if that occurs, if the oracle notifies the smart contract that occurs, then the $100,000 policy is automatically returned to the farmer. Farmer automatically gets a payout rather. So the payout is not necessarily dependent upon some kind of approval process or some kind of court coming in and finding that the insurance company needs to pay. It's an automatic smart contract payment that comes through based on this event of 5+ 95 degree days. Now, unlike a beer vending machine, you really can't open that up and look at the mechanisms and confirm that you're going to be paid off, you're going to receive the beer if you put the money into it. In the case of a smart contract, you can audit the smart contract and kind of guarantee for yourself that if you put your money into it, and if these conditions occur, then you should see the payout coming out for the back end of that. So a huge advantage over a traditional contract.
Yes. So what is blockchain? Well, smart contracts are simply one application of blockchain. So what is blockchain as a whole? It's like asking what supply chain management is. It's, well, you could say, well, which part, right? So I'm going to go through a tiny bit of history behind blockchain and Bitcoin specifically, and then go into the different types of blockchains, and then finally go into how blockchain functionally works. Blockchain technology was first introduced in 2008 as an underlying technology for the digital currency Bitcoin. It was invented by an anonymous group or one person who is labeled as Satoshi, Nakamoto, a Satoshi is actually 0.000000001 of a Bitcoin, which I'm filling your heads with useless information now. The idea behind blockchain technology was to create a decentralized and secure ledger that could be used to keep track of all the transactions made using Bitcoin. So in the Bitcoin white paper, which white papers are the go-to place to get a high-level sense of any kind of cryptocurrency or blockchain technology, so just search white paper for XYZ of whatever project you're looking at. He actually, in this white paper, only mentions chains of blocks. So the term blockchain was actually more coined when we start talking about Ethereum. So the key feature of blockchain technology is that it uses cryptography to secure the transactions and prevent any changes from being made to the ledger, the list of transactions, once a block has been added to the chain. So this makes blockchain technology extremely secure and resistant to hacking or tampering. So I'm gonna try to make this as easy as possible because there's 4 different types of blockchains. Again, somewhat useless, but I think it's a fundamental building block here. 2 of which are the most popular. So public blockchains and private blockchains. Public blockchains are open and decentralized, allowing anyone to participate and validate transactions. Examples would be Bitcoin and the original Ethereum, which we'll talk about here in a moment. Private blockchains, which are going to be like the farming example that Stephen gave, and most of the examples that we'll give later on, which are permissioned and controlled by a single entity or a group of entities. They're usually used for a specific application in supply chain management, finance, or healthcare, and like Everledger, MetaLedger, which we'll talk about later. There's also consortium and hybrid blockchains, which are typically like nonprofit organizations or where there are groups of organizations that jointly manage the network. Okay, so that's how you describe the ultimate purpose or the kind of organizational structure, if you will. Next slide, please, Stephen. Now we'll go into how blockchains actually work. So the 2 most common ones are proof of work and proof of stake. So these are consensus algorithms, meaning there needs to be a consensus reached along the network based on the algorithm to put that block onto the chain for that transaction to complete. So a proof of work chain is a consensus mechanism that is used by Bitcoin and Ethereum and most of the major blockchain networks, kind of more of the older style, which I'll get to when we talk to proof of stake. But it was designed to ensure that the security and integrity of the blockchain by requiring participants to perform a certain amount of computational work or solve a mathematical puzzle in order to add a block of transactions to the chain. This process is known as mining, which I'm sure you've all heard of, Bitcoin miners and all the energy it uses. And I have some really cool statistics later on. But these are used to validate transactions and create new blocks. So miners compete with each other to solve this puzzle. And the first miner to solve it is able to add the block to the chain. Well, this block contains the transactions that have taken place since the last block was added. Don't get bogged down with that, but the miner is then rewarded with a certain amount of the network's cryptocurrency or tokens for their effort. The reward incentivizes miners to participate in the network, secure the blockchain, and validate transactions. So once a block is added to the chain, it cannot be altered, which makes the proof of work mechanism a very important part of the blockchain security. So the computational work required to add a block to the blockchain makes it extremely difficult for a malicious actor to manipulate the blockchain and add fraudulent transactions, as it would require a vast amount of computing power to do so. So proof of work systems devour a tremendous amount of electricity, which I'm sure you've heard in the news. The news loves to talk about this. Bitcoin mining, for example, currently consumes electricity at the annualized rate of 127 terawatt hours. That's now higher than the power consumption of the entire country of Norway. With proof of work, Ethereum had an annual power consumption roughly equal to the size of Finland, producing a carbon footprint similar to Switzerland, which I don't know if that says something about Finland and Switzerland, but anyways, proof of stake is the other consensus method. So this is the alternative. This is the new school. You can think of proof of work as old school and proof of stake as new school. So unlike proof of work, where miners compete to solve complex mathematical puzzles to validate the transactions and add blocks to the chain, in proof of stake, the validation process is done by validators who hold a stake or ownership in the network. So here's how it works. Step 1, Validators are selected. A new block creator is selected based on the number of coins they hold. So the more stake a validator has, the higher their chances of being selected is. Now, validators can be anyone who owns whatever cryptocurrency or tokens of that network. So step 2 would be then the validation. So the selected validators are responsible for validating transactions and adding blocks to the blockchain. This is done by proposing a block and then validating it through that consensus process, aka the validators. So just by simply participating and staking your wallet or your amount of coins or tokens, you now then become a validator. So the validators are then rewarded for their role in maintaining the network security and stability. This is done by distributing newly minted tokens or transaction fees back to the validators. So in the event that a validator is found to be acting maliciously, their stake is used as a penalty. This disincentivizes bad behavior and helps maintain the security of the network. So in summary, since proof of stake is a little more ambiguous, proof of stake is a more energy efficient alternative to proof of work and relies on validators holding a stake in the network to validate transactions and maintain the security of the blockchain. Proof of stake blockchains use 99.8% less energy than proof of work blockchains. Next slide, please, Stephen. So I spoke a little bit about Bitcoin, but I believe the next generation of blockchain technology and pretty much anything that we're going to talk about in the rest of this deck will rely on what is called as the Ethereum network. So Ethereum, Ether is the token or the coin that is backed by Ethereum, and now they're merging it into Ether 2.0. So whenever you go out and look at Ethereum, make sure that you're looking at Ethereum 2.0 because that's the new school stuff. Ethereum is a decentralized open source blockchain platform that enables the creation and execution of smart contracts and decentralized applications. So decentralized finance, and etc. So it has its own cryptocurrency, Ether, like I said, ETH, which is used to pay for transactions and computational services on the network. So Ethereum has a much broader capability compared to Bitcoin and provides developers with the tools to build decentralized applications that can automate complex processes, reduce intermediaries, and increase transparency and security. So I know I've gone pretty deep on that, but this next part is, I promise, is the deepest I'll go, and then we'll come back up to earth, or come down to earth. Let's say that. The merge, which is what I referred to earlier, is the new Ethereum. So the Ethereum network was a proof of work consensus, and now they're moving it to proof of stake. And so I expect this will allow Ethereum to scale its transaction throughput, much further reduce costs, and enable applications to drive greater utility on the blockchain. Once this merge happens, Ethereum is expected to reduce its carbon footprint by up to 99.95%, which would obviously address the major criticism of the majority of cryptocurrency. So in summary, while Bitcoin primarily serves as a means of payment, Ethereum offers a much more flexible platform for developers to build and launch their own decentralized applications and services.
Yeah, great. A great example of that is what's happening with decentralized finance. And we're just going to kind of run by this one because there's a whole bunch of webinars you can do just on decentralized finance. But I use this example, I guess, of how we use blockchain to, create a more equitable, maybe egalitarian approach to the way finance works. So in the case of this crop insurance policy that we were creating before for the African farmers, the old way of running this would be you'd have a giant company that put up a whole bunch of money that would essentially, fund the policy and populate that insurance company vending machine with money that would justify the policies behind it. But with blockchain technology and Ethereum in particular, what you're able to do is have a group of investors all put in varying amounts and then have a separate smart contract set up so that once the condition is met that enough money has been put into the account, that is, once enough investors have totaled up their investments up to $100,000, then it instantiates the crop insurance vending machine for the farmers to go out and work with. So it's a way of having a group of investors, just like the group of people around a table at a bar, all putting in money for the pitcher of beer. a group of investors are able to pool their money together to create one of these contracts. And then if there is a return, hopefully there would be, that gets returned back in proportion to the investors who were in place originally. So it's decentralizing finance, and decentralizing is going to be a theme really throughout the entire presentation. In the idea of a blockchain, you have a group of a very, very large group of servers and computers that are all managing copies of that blockchain. And it's decentralized across many, many different organizations. It's not just in one person's data center. So that's one of the reasons why it's so secure, because it's impossible to hack into thousands of computers around the globe. So we'll get a little bit further into what decentralization means and what the benefit of that is too. You're muted, Michael.
Yes, thank you, Stephen. So which brings us to the last heavily technical part of the presentation. So I appreciate everyone for bearing with us. So tokens, as you can see, we have coins and tokens, and they're somewhat interchangeable, but I'll obviously delineate the differences here. A coin, which is like Bitcoin or Ethereum or Ripple, that's acts as like a digital currency. A token is like the Starbucks points. It's like a rewards point that you can only use within a certain ecosystem. So like I can buy Ethereum with Bitcoin and vice versa, but I need to put money into VeChain or Byton or Tron to then interact with the applications and computational processes within those ecosystems. And then on the right there, and I'll go into this later, but non-fungible tokens, which I'm sure you've heard of, NFTs, and fungible tokens, intangible and tangible. So the tangible idea of a token is like a fungible currency is a coin, right? Well, the digital version would be Bitcoin or Ethereum or carbon credits, which Stephen will go into next. So I think that's kind of one of the most interesting use cases coming into the future here. So in the world of blockchain and cryptocurrency, a token refers to a digital asset that represents ownership of a certain unit of value or utility, such as a certain amount of currency or access to a specific application or service. So tokens can be used for a variety of purposes, such as representing assets in the real world, acting as a medium of exchange or store of value, and facilitating access to decentralized applications. So tokens are typically built on top of existing blockchain infrastructure, such as Ethereum, and are usually created through a process called initial coin offering or an initial token offering, much similar to like an IPO when a company issues shares when they first go public. The most well-known type of token is the cryptocurrency, which acts as a digital currency, like I said, and can be traded on various exchanges. So coins are cryptocurrencies that are based on their own standalone blockchains. Tokens do not have their own blockchain and live on existing ones. Example, if the token is being created on Ethereum, it cannot be used on other blockchain platforms. So coins that are primarily used as a medium for digital payments, while most tokens are used to execute smart contracts, raise funds for crowd sales, or be used as rewards. So to make this a little more clear, a real life example is like a Starbucks. You go to Starbucks, you have Starbucks stars, and each time you buy coffee, you get some Starbucks stars. Once you accumulate enough stars, you redeem them for a free drink. So these stars are tokens, and the money you spend on Starbucks products is the coin. So you can use Starbucks stars, you can buy Starbucks stars using dollars, but you cannot get real money for the stars. So following the same analogy, a crypto coin can be used to buy a business's token, but not the other way around. So tokens in proof of work and proof of stake blockchains serve a similar purpose as a unit of value or representation of assets. So, however, the way that they're generated, distributed, and maintained differ between the two consensus algorithms, so proof of work and proof of stake. So in proof of work blockchains, tokens are generated through the process of mining, which involves solving complex mathematical problems to validate the transactions and add new blocks to the blockchain. The tokens in proof of work blockchains are often rewards for the miner who validates the transactions. So on the other hand, tokens in proof of stake blockchains are generated through a different process called staking, where token holders can stake their tokens as a collateral to validate transactions and add new blocks to the blockchain. These token holders receive the rewards for participating in the validation process and help to secure the network. I know I repeated myself there because that's kind of the crux of cryptocurrency is this concept. So to finish off this slide here, non-fungible and fungible tokens. A fungible token is a blockchain. In a blockchain is a type of cryptocurrency or digital asset that represents a unit of value that is interchangeable with other units of the same value. This means that each unit of the token is equal in value and can be traded or exchanged for another unit of the same token, just like physical currency. Examples of fungible tokens in blockchain include Bitcoin and Ethereum. A NFT, a non-fungible token, is a unique and indivisible digital asset on a blockchain that represents ownership of a one-of-a-kind item or piece of content, such as a piece of artwork, music, even a tweet, definitely the deed to a house. Unlike fungible tokens, like cryptocurrencies, each NFT is distinct and cannot be replaced or divided into smaller units without losing its value or uniqueness. So they are verified and stored on a blockchain, which provides the secure and transparent record of ownership and provenance. Next slide. Thank you, Stephen.
You bet. So some great examples of fungible tokens are carbon credits and how they get exchanged. Carbon exchange. So fungible tokens are just to repeat a point that you made a second ago, Michael. Like a fungible token is like a dollar bill. Like it doesn't matter which dollar bill you're holding; they're exactly the same, right? $1 bill is not worth any more than another dollar bill. So fungible tokens are being used on the blockchain in order to fund green projects, things like putting up windmill farms or putting up green energy projects around the world. And this is actually one of the requirements coming out of the European Union at this point. But the idea is this, is that a company that wants to displace some of the carbon that they create by operating, they want to get to that zero carbon footprint by 2026 or whatever the year might choose to go buy carbon credits. And those carbon credits are fungible tokens that represent green projects that are done elsewhere in the world. So by using blockchain technology, the company knows that by buying this carbon credit for X number of dollars, that money is eventually being passed through to other organizations that are putting up all these wind farms or putting up electric vehicles or whatever might be the green credit project that displaces the carbon that they're creating on their side of the world too. So it's a great example of how blockchain technology creates this secure exchange, and fungible tokens in particular are pretty effective. One other point I wanted to make as well around blockchain technology is, probably Bitcoin is the most well-known example of blockchain technology, just because it's in the news constantly. But obviously we're talking about other blockchain applications besides cryptocurrency in this case, and Michael did a great job of talking through the ways that technology is a little bit different. So while we'll go through some examples of other companies that are using blockchain, I should say probably that none of these are using Bitcoin specifically. They have a common ancestor, I guess, between the two branches. So 3 good examples of that in healthcare are the 3 companies I have listed here in front of you. So Patientory is a startup that's working on a blockchain-based technology and a smart contract-based technology that allows for medical records to be owned or held by the individual and controlled by the individual, though it is stored on the blockchain, stored in this distributed fashion out on servers out in the world. So, the old way of doing this, of course, was when you got a referral from your general physician over to somebody else, they had to transfer the records, using, a fax machine or something like that from one database to another database, or from one, filing cabinet to another filing cabinet. And Patientory is saying, how can we use blockchain in order to keep those contracts out in the ether somewhere on the blockchain? And then I'm able to, as a consumer, walk into a new specialist that I'm going to see and, grant them access to those records rather than having to transfer them from one office to the other. So that's something that I personally would really like to see. There's also an organization called the Institute for Risk-Stream Collaborative. This is an association of insurance companies. So insurance companies have a really interesting requirement and application here. If you're in a large insurance company, then every 90 days, you have to call all of the doctor's offices and care providers in your network and confirm things like their fax number, like their address, make sure the doctors that you're working with are still working there, just the basic details and information, which is one of the requirements they have to live through. So I mean, that's awfully ridiculous, right? If you think about all the insurance companies in the country, and all those insurance companies are literally making the exact same phone call to all of those doctors' offices, there's an immense amount of redundant work happening there. So a blockchain development company we'll talk about later developed this application for it where you're able to store that information about provider data on the blockchain on this decentralized database that no one insurance company has access to. But then all of the insurance companies are able to contribute information to it. So they're contributing, the Dr. Jones works at this office now and his phone number is this and that kind of thing. They can all contribute information into this database, and then all of them can pull information out of it as well. And then the incentive or the reason why you would go to the trouble of updating the database is that you're rewarded, essentially you're paid for adding information to the database in the first place. There's also other mechanisms in place for correcting errors or challenging other companies' submissions of data, and that's a way of validating the information to make sure it's correct. And then the final healthcare example is a company called MetaLedger. So healthcare, particularly pharmaceuticals, have requirements around understanding how the progeny or how the drugs are actually created, the supply chain that gets the drugs from the factory to the pharmacist and eventually to the end user. And they have a lot of requirements around that. If you don't know where the drug came from, if there's a possibility it could be counterfeit or a possibility it could have been contaminated at some point, then the drug has to be thrown away. So what MetaLedger allows you to do is, trace where a specific drug or a specific, pill box has been throughout that supply chain, all the way to the pharmacist. And then if the pharmacist needs to return that, they can do so. They can return it to the factory, and MetaLedger keeps up with the transaction going back, which is something that heretofore wasn't really possible to do. So it used to be the pharmacist would have to literally throw out some of the medication because they weren't able to prove where it had come from and how it ended up in their office in the first place. MetaLedger prevents that and avoids a whole lot of waste in the system. So that's one of several supply chain examples, and that's really where the rest of the presentation is going to focus. Supply chains are immensely complex, as everyone on the call I'm sure knows. There was a Harvard Business Review article a few months ago that talked about just how complex supply chains are. They said that an average product has about 14 suppliers behind that. And each of those 14 suppliers have another 14 suppliers. And each of those second-tier suppliers have another 14 suppliers. So you can see how very quickly a very simple product like a mug or a book or something like that on a store shelf actually has thousands of companies involved in producing that product and getting it on the shelf. So creating better visibility and being able to trace things as they pass through supply chains is a high priority, particularly for everyone in the Institute for Supply Management. So we'll talk through authentication, alerting, visibility, and payments, and the way that this technology is really kind of revolutionizing the way this all happens.
Yes. So to begin our journey down the path of logistics and supply chain management, all of the rest of what we're going to be talking about will be in that realm. So OpenPort is a company that operates with blockchain technology and offers solutions for supply chain management. But the company utilizes blockchain as a distributed ledger to transmit orders, letters of credit, bills of lading, delivery receipts without the need for intermediaries. So this ensures that it's secure and undisputable record keeping of these events in a digital format. So OpenPort's platform aims to solve one of the biggest challenges in the modern supply chain, which is the cash flow problem.
Yeah, anyone who's ever been involved with importing or exporting goods knows how complex that can be with the bill of lading, the letter of credit, and making sure things get transferred on time. OpenPort has some really interesting solutions. There's another one here called SkuChain that is focused more on the payment side. SkuChain's earlier in their development, so it's what I would call a startup. So the SkuChain is going after similar kinds of things. So one of the ideas is replacing this letter of credit with what they call a distributed ledger of payment commit, a DLPC. And the DLPC allows companies to be able to deliver goods and trust that they're going to be paid on the back end for delivering those goods. It also allows credit to be able to flow through the supply chain to second tier and third tier suppliers as well. One of the things that happens with importing goods is a company makes a commitment to buy some product from a factory overseas, and then that factory starts producing the goods, but that factory also has other second tier and third tier suppliers who are producing raw materials for them, or maybe some kind of component that goes into it. Well, the first factory is able to work with some kind of a financial institution to be able to fund the development or the production of the product that fulfills the PO or the order coming from the company in the US. But that needs to be able to flow through to the second tier and third tier as well, because everybody needs that funding to be able to produce those costs of goods or those materials that ultimately end up in a product that we consume here in the US. So SKU Chain with a DLPC is able to extend that credit letter all the way through second tier and third tier suppliers and create more liquidity and funding for other organizations that the original person or the person who originated the PO may not even be aware of. They're also developing what they call a collaborative resource planning platform. So everyone knows what an ERP is. ERPs are loved and hated by everybody on the call, I'm sure. But a collaborative resource planning allows you to organize resources across multiple organizations and plan for that. So because smart contracts and blockchain is distributed, it's not owned by any one organization, and it's out on the blockchain somewhere else across this large network. There's no one organization that owns it. No one organization is responsible for the entire thing. So two different companies that may in some sense compete or at least be skeptical of one another are able to trust that the information stored in this database is accurate and correct, and they're able to have some level of relationship based off of that. Michael, VeChain.
Yes. So VeChain is unique in the sense, and actually, let me back up. So all of these that we're talking about are all built on the Ethereum blockchain. So when we talk, this is the transaction that goes on the blockchain. Typically, we're talking about Ethereum, but that doesn't mean that that anyone can't just go and build their own blockchain. Anyone can do that. So VeChain is unique on this list because it is its own blockchain. So they own everything from the ground up. VeChain, they aim to enhance supply chain management by providing a secure and transparent way for businesses to track and verify their products and services. So they offer solutions which a bunch of different industries, specifically luxury goods, agriculture, logistics. But VeChain utilizes a unique combination of blockchain and RFID technologies to give stakeholders the ability to access real-time information about a product's origin, quality, and authenticity. The platform is built on the proof of stake consensus mechanism, which enables it to process transactions super quickly, securely, and efficiently, while also ensuring that the network remains decentralized, which is one of the most important parts here. VeChain also has its own cryptocurrency, VET, because it's its own blockchain. It has its own cryptocurrency. This is used to access the platform's various services and to pay for transaction fees to use the applications that sits on the VeChain blockchain.
Yeah, great. And then LinkLogix, just to kind of complete the slide out, they have also developed some things similar to what SKU Chain is putting together around it being able to extend that PO financing down to second and third tier suppliers and just facilitating that bill of lading versus letter of credit transaction that happens when you import goods. A few other companies around alerting then we've listed here. The first one is rather interesting. Pixelplex I have a little bit of a relationship with, a few conversations. It's really a blockchain development company, and they've developed a few different solutions. One called Scargos, which is a freight shipping or blockchain technology, which allows for GPS tracking across shipping and trucking. So whether it's on the container ship or in a truck, they're able to know where it's at. They've also developed Block Verify, which is an anti-counterfeit solution. So you know that the Nike sneakers that you buy are actually Nikes, or that the wine that you buy is actually the wine from the vineyard that it's supposed to be from. And then they've also developed a number of products around alerting. So the example they gave me was one of the large server manufacturers uses their technology along with a sensor to be able to monitor the conditions of a truck as it goes across the country. So the idea is if they're shipping, $1 million server from one part of the country to another part of the country, they need to know if that truck went over railroad tracks at 50 miles an hour and that there was some kind of jostling that may have damaged the server in transit. So Pixelplex developed a technology using blockchain and distributed ledger to be able to monitor the conditions of that server in the box and make sure that no damage happened.
So Tive is kind of similar, and this is probably one of my favorites on the list because they actually have these products. So as you can see there on the right, the Tive tag is just one of their products, but it's a physical tag that you can stick on a box that measures temperature, and it's just like a sticker. It's the thickness of a sticker. It has a battery, remarkably, and it lasts 100+ hours, and it uses Bluetooth to transmit that data then to a larger network. But it was specifically designed to capture and transmit its shipment data in real time with super high accuracy. So the other product would be it's a little box, no bigger than like half the size of a smartphone, typical smartphone. And this one can actually track GPS location and transmit that data via GPS. It also tracks temperature, light, humidity, and shock sensing, just like Steven said with the expensive server equipment. It's like, for instance, Tive would be used to verify shipping conditions for cold or frozen products or highly valuable shipments like artwork or expensive server equipment. So all of this data can be displayed on their platform where you'd be able to view your shipments in real time, set up alerts and notifications, and then generate reports and analytics. So Tenderly, the next one on the list there, is a monitoring, management, and analytics platform that provides users with real-time visibility as well as insights into their operation of their blockchain-based applications and infrastructure. So this is more of a platform where you can develop applications on and then track and report on those conditions. So the platform enables developers, operators, and stakeholders to monitor, troubleshoot, and optimize their blockchain systems and provides various tools for debugging and performance analysis. Tenderly aims to simplify the development and management of blockchain-based applications, making it easier for developers to build and maintain robust and secure systems. So additionally, the platform provides a super user-friendly interface that makes it accessible to a much wider audience, including non-technical users. So a non-technical user could go in and develop a blockchain-based application that fits their own needs. So overall, Tenderly's goal is to make blockchain technology more accessible and easier to use, enabling organizations and individuals to adopt and benefit from blockchain.
Yeah, great. And then you're probably getting the sense that visibility and understanding where packages are is one of the big themes here. So there are a few examples of different companies that are improving visibility as products move through the supply chain. SyncFab is an interesting organization that's focused specifically on the medical and the aerospace industries. Both, the medical industry and the aerospace industry need to understand where products are in the supply chain, and they need to be able to verify that the part that they ordered or the drug that they ordered came from the factory that they think it came from, used the raw materials that they intended for it to use, and was developed to spec the way that they wanted it to be developed. So SyncFab is also one of these distributed ledger technologies that tracks product as it moves through the supply chain, and they can understand exactly who is building and working on this, and they can verify that so that when they get the end product, they know that it's not been contaminated or in some way counterfeited by some other piece.
Yes. So Everledger, again, stacking on visibility, it provides tracking and ownership of the and provenance of high value assets. So specifically like diamonds and fine art. So leveraging blockchain technology, Everledger creates a secure, transparent, and tamper-proof record of asset ownership, making it possible to verify the authenticity of the asset and track its movements throughout its entire life cycle. So this helps with fraud and counterfeiting while providing greater transparency and accountability in the high value assets market specifically. T-Food switching from high value to, if you will, maybe higher value food, as a blockchain supply chain management platform for the food industry. It aims to improve transparency and traceability in the food industry by providing a secure and tamper-proof ledger for tracking food products from farm to plate. So the platform leverages RFID technology, QR codes, and mobile applications to provide real-time visibility into the entire food supply chain. So you allow stakeholders to monitor the movement of food products, verify their authenticity, track the journey of food products from origin to consumption. This helps to improve food safety, prevent fraud, and reduce food waste.
Yeah, and then finally, MetaLedger, I mentioned earlier, but this is a technology that's allowing us to track pharmaceuticals as they're manufactured and distributed, and as they eventually end up in your cabinet at home. So all of those improve visibility, and those were the examples that we had of smart contracts and blockchain, specifically around supply chain kinds of things. And that's those are the slides that we had, I guess. But we would welcome any questions or comments or anything else you guys would want to talk about.
Yeah, if anybody has any questions, please come off mute and pose your question to Stephen and Michael.
Hi, can you hear me?
Yes.
Yeah.
Yes, this is Luis here from Apex. What did you guys have? How did you guys feel that or notice has been the response from businesses on these offerings? Do they still skeptical and or maybe it's too costly for them? Or is the vast majority, or is a good bunch of business actually rolling into these type of technologies?
Yeah, I mean, what I've seen so far is that blockchain and smart contracts are still a little ways out, right? It's cutting edge. So this is not as much a conversation with the CEO of a big company. It's more like a ventures group or some technologist who's really interested in those kinds of cutting edge kinds of things. So we haven't yet really seen any of these companies scale up and become major players and really establish the market quite yet. But that being said, I think there's a lot of application for it. And I think that there are some very large companies like I mentioned, the computer manufacturer that are using this to really solve real world problems. So I think we're going to see this over the next few years take off and become a much more commonplace conversation, at least among people who are managing supply chains.
Yeah, and if I may add to that, blockchain is super complex to code and develop. So those resources to create these applications are very expensive. So like Stephen said, it's going to be the early adopters who are leveraging it. But as more platforms, low code, no code platforms come out, that will enable, so if anyone's familiar with like Microsoft Power Platform, Power Automate, or those no code, low code applications, it will allow non-technical users to develop applications that sit on top of blockchain. So that's where we're really going to see widespread adoption, is when you can give someone who doesn't necessarily need to know anything about the technology, they can go and then build an application that they don't even care if it's on blockchain. You get the benefits of blockchain being immutable, decentralized, all of that, but now it's just created using natural language. So,
yeah.
Any other questions? You can come off mute and ask your question. Now's a good time. Hi,
Well,
Tom, do you have a question?
No, I just waiting my turn.
Okay. Oh, we do have a question here. I work in a NGO being tied to US government funds. Do you think blockchain will, let me see, it just came off, will ever infiltrate into government business?
I think it will. I don't know that cryptocurrency is necessarily going to be adopted by the federal government. But I think blockchain is just so valuable, it's going to have to be a part of how they move things around in the government. Michael, do you know of any examples of the government using blockchain quite yet? Well, it was the city of Miami, I think, that offered a cryptocurrency. It did not go well. It
Yeah.
did not go well.
Right.
But in terms of smart contracts, I think it's everyone will eventually be using them. The technology just needs to be developed a little further and adopted more widely.
Yeah, exactly. And going back to public versus private blockchains, like you can develop a blockchain like which I'm assuming will happen. The government will build their own blockchain, which then they'll build their own applications, which are certified and fall under the governance and compliance of the government. That will be most likely what we'll see is a USD, like a USBC, like a United States blockchain. Like that will be the standard that they'll use. That's what I see and what the community sees.
Yes, that would be wonderful because compliance is so huge for what we do, but yet I don't see blockchain coming to us anytime soon.
Yeah, I'm sure. There are some other applications around things like ESG requirements, environmental safety governance requirements too. So being able to, provide evidence that the product that the suppliers you're using or the products that you're selling meet ESG standards. I think that might be kind of related to this, right? Because the government obviously has some compliance requirements that could be, there could be proof that you've met those requirements using some kind of blockchain. That'll be interesting to see where that evolves.
Thank you.
So,
Thank you. Any other questions? That was good. Thank you. Well, it looks like our time is almost over. I want to thank both Stephen and Michael for presenting this topic to our ASCM and ISM community. And Tom, do you have any closing remarks before we close out the evening?
Well, I just want to echo your comments, Stephen and Michael. We really enjoyed the presentation of some great information and a nice learning night. So thanks again.
yeah, thank you, Tom. Appreciate it. Thanks, Kathy.
Oh, you're
thank you.
welcome. You're
Thank you.
welcome. Well, thank you, everybody. I'm actually going to stop the recording at this point.